And that's something we'll practice with. Okay. Can I erase some things? Give me jazz hands if I cannot, if you're still using it. Haha, I got you. Alright, so I'm going to erase some things just because it's getting busy, and I don't want to overwhelm for these last couple things. And again, if you did have something you needed, I'm recording this 2 different ways right now. Since last week we had the issues where it wasn't there for me to save the recording. It didn't save it right. So hopefully today it does work. Okay, so increasing and decreasing. Where is this function increasing? What x values is it increasing over? Same idea as concavity. I'm looking for something in this format. And there is more than one place it's increasing. Just give me one of them. First of all, maybe we didn't do this. What is increasing? What does that mean? Your value, and which value? I mean, because x is always going to go up because we're going left to right. So what's happening with the y? The y is the thing that's increasing as the x increases. So where is that happening?
Negative infinity to negative 1.4.
Negative infinity to negative 1.4. Perfect. That's it. That's what I'm looking for. All right. And I know that that's my bell. If you can stay after, please do, because I do have a couple more things I want to go through. Not much, but a little bit. Where am I then decreasing?
From negative 1.4 to positive 1.4.
Mm-hmm. And then what happens after positive 1.4? I start
Increases again.
Increasing again. Okay, so this might feel a little different, this part right here. I don't know that we spent a whole lot of time with it last year. I know my class did spend some time with it. But again, pre-calc, I didn't teach your class, so I don't know. But this is going to be something that's going to come up this year. Most absolutely. All right, x and y intercepts. What are the x values of the x-intercepts?
Negative 3.
Close to negative 3. Is approximately negative 3. And it looks like that's the only one in this case. Sometimes you'll find functions that have an infinite number of x-intercepts, but because we use functions, we typically only have one y-intercept. And where is that?
8.
Y equals 8. Does this have symmetry?
It has odd symmetry.
It almost has odd symmetry. Because it's been lifted up, it actually kind of throws us off on the odd symmetry slightly. But it does have that odd shape to it. With the odd symmetry, we still are going to look at when it's centered around 0, 0, and this is centered around 8. So, I mean, that's... I don't disagree that it has odd symmetry, but because it's been shifted up, I'm going to be careful about calling it symmetry. But it is an odd shape, for those of you who haven't done even and odd. This most absolutely. Especially if it was centered at 0, 0, then I would call it an odd symmetry. All right, and shape, how did you describe the shape? I'm hoping to get at least 3 or 4 different answers.
An S, like a roller coaster.
I heard an S. I heard a roller coaster.
I put a snake.
A snake. I've got a praying inchworm. However you want to describe shape, I will take it. That is 100% always going to be up to you. Okay? All right, I'm not going to go through the other 2, but I do hope that you practiced them and that you will practice with them if you haven't finished yet. Like I said, I've got one more thing I want to do quickly before we say goodbye. And I do have I want to check and make sure you remember how to do these sort of problems. Okay, so and I mostly want to just verify because of this last one. Okay. Do you remember what this notation means? Keaton.
Does it mean whatever's in the f you replace for x to see what f of x is?
Because we normally have f of x, if we replace the x with something, like f of 2, what it's saying is x equals 2. And you're going to replace the x's then in the function with, or, 2. Okay, you're going to replace the x's in the function with that thing. So, that means that f of negative 2 would start out looking like this, right? And from there you'd go through and you'd simplify. And occasionally, we'll have situations, depending on the function you're playing with, that technically, yes, this is an imaginary number, but imaginary numbers do not exist on graphs. So I would refer to that as a does not exist function. Okay, the reason I really wanted to pull this up, though, is I am giving you some homework problems that look like this. How would you handle that when it's got more than one term? Bless you. Would there be a difference in how you handle it? Nalina, you're right. There's not. Whatever's inside the parentheses replaces the x, and I'm going to put parentheses here to show that this is where the x was. And then I simplify it, and because they are all unique symbols, that's as simple as it will get. Okay? This right here, as early as our next lesson or the lesson after that, is going to be a notation we're going to use, and it is specifically going to be x plus delta x. That has a very specific meaning that I will get into on one of our next lessons. Okay? And then the one other thing I just wanted to verify with you before I leave you, because I am throwing this in the homework too, is piecewise functions. I know we've all played with them. I want to just verify we know how to use them, though. How does the problem change from the last thing we did to now once I put this into a piecewise function?
You just put it into the equation where the x matches what's in the where the x boundaries match what's in the f for the things. Other than that, it's pretty much the same.
Same thing, but you do have to match your boundaries. And I saw Mia also unmuted herself. Is that what you're going to say too?
Yeah, like you have to match up your x with like the boundary that has the other x.
Perfect. So when I look at -2, which boundary does that fit into? Is -2 less than 1 or is -2 greater than 1?
Less than.
Less than. So therefore, it's going to fit into this function. So I'm going to say, I'm going to use the x squared function and plug the -2 into that. What about 0? Is that less than or equal to 1, or is that greater than 1?
Less than.
It is less than. So we are going to use the same function again. I'm realizing how dull this problem is because we keep using the same one over again. What about f of 1? Is 1 less than or equal to 1, or is it greater than 1?
Equal.
Equal, so again, like I said, we keep using the same function over again. In your homework, it is going to switch between the functions. I happened to pick one that did not. I'm kind of sad about that. And by the way, I should also add, yes, you would then simplify each of these. Now, what about this last one? Making you think on this one.
Greater than.
Why?
5 squared is 25, and so it's 25 plus 2, which would be 27.
Well, that is correct, but this is actually, I'll make a cursive one. This is the letter S.
Squared can be negative, so it would have to be greater than 1.
Squareds cannot give you, they cannot yield a negative number. We're not dealing with imaginary numbers here. So just by virtue of the fact it's squared, we can logic our way through the fact that this is a positive number, whatever the positive, and the positive number doesn't even have to be greater than 1, it's just a positive number. And we're then adding 2 to it. And any positive number plus 2 is definitely going to be greater than 1. So on this case, we switch to the other function. And this one you can choose if you want to simplify it or not. I'm not upset if you choose not to.